So all this time, 70E, 70B, they have been advisory standards, but enforceable by non-compliance. As in, you can do what the heck you want, but if there's loss of life, loss of limb, an incident, OSHA comes to your site, they'll cite you for not following these standards, for not doing maintenance.
Hey, and welcome to the Electrical Safety Podcast. I'm your host, John Travis, and today we've got Sam Pherwani with us. Sam has got more than 30 years experience in the electrical industry, and I think about 12 years experience in electrical safety. He's done all sorts of things as far as training goes with NFPA 70E, as well as helping people develop their electrical safety programs. Sam, thanks so much for coming on the show.
Yeah, hi John. Good to see you again. And I always look very fondly upon the good work we've done together in mining and other sites all across extreme parts of the U.S. and Canada. It's always been fun.
Yeah, it was good to see you. Sam, just for people listening, I always like to start off because I'm interested in it myself and just how people find their way into the electrical safety world. It's always interesting, kind of bit of your backstory and how you end up doing what you do today.
Yeah, I started out as an instrumentation controls tech and went back to school, got a degree and became a controls INC guy, controls engineer. And I did a lot of stupid things when I was young. We'd troubleshoot why the PLC wasn't able to start pump or a motor. I'd take a meter and we'd check 24 volts this side of the coil. PLC starting and stopping it, no problem, but pump ain't stopping. So I take the same motor, the same meter, change the range to 600 volts, go check 480 with bare hands with a meter, check it's working on that side of the relay. Like somebody says, "Hey, Pherwani, your circuit ain't working." So we didn't have a separate instrument tech or a separate electrical department. And later on, when I was paired up with the senior journeyman, he said, "What the heck are you doing? 480 will kill you. It's three phase. It doesn't forgive like 110 or anything under 50 volts." So when I got the chance to work at an electrical substation, two electrical substations, and setting up a DC transmission line, I got renewed respect for energy. The higher you go, when you cross the 1 kV threshold in the medium and in the high, what it can do and the hazards, the real hazards of induced energy, not just three phase by contact for electrical shock and arc, but what the magnetic field ghost voltages can do. I started to reorient my career toward electrical safety, saying this is more exciting than putting circuits together, building stuff. I want to save lives because lots of people are trying to build or operate or maintain or troubleshoot electrical equipment with phenomenal amounts of three-phase energy, and they don't know what they're going to do. It ain't forgiving. It's going to kill them. So this is the road I want to be on.
Yeah. Now I know you've got your NFPA 70E certification for training, and that's one thing I think a lot of people maybe don't know about. So if you could take a minute, I'd be curious to know, first of all, what exact the term is, and then how do you go about getting that, and what does it really show that you maybe.
Yeah. So after the substation project, I went to work in California at Berkeley Lab, and that was a requirement there. They wanted for you to be in electrical safety. The electrical department wanted that certified electrical safety compliance professional certification, which means you have to go through a barrage of training, NFPA 70E approved training. So you can't go just about any place. And there's theory, written material. You take a 3-hour test. It's all multiple choice, but they're tricky. All of the answers seem correct, and sometimes they have double negatives that confuse people. So, yeah, but you get the CESCP. I didn't stop there. This year, I did the CUSP as well, which is the Certified Unit utility safety professional. So NFPA 70 ESCP primarily covers safe work practices, know-how, so you can teach and help companies with low and medium voltage. That's utilization and distribution. But the CUSP can help me complete the spectrum, adding transmission there as well, power lines, etc.
Yeah. Yeah, that seems to be something that I know we had Mike Barr on the podcast early on, but outside of him, there's really not a lot of people that seem to be teaching that stuff. Um, what what do you find that maybe are some of the gaps in the utility or transmission and even the substation world as far as it comes to electrical safety?
Sometimes you leave the plant, you go out in the cage where your substation is, you're following it backward to where the feed from the overhead or underground power lines coming to your mains transformer. Some people don't have to worry about that mains transformer because it's in the scope of the power company. So it's like those guys come in and they do their thing and they treat the transformer as a black box. Some people do not realize that the feed to the transformer is in the scope of the utility. However, the actual transformer and its maintenance is in the scope of the company that where the transformer sits on their real estate. So
Yeah.
they realize at some stage the plant manager is like, "Oh my god, I have a transformer. I'm supposed to maintain it, and I have done nothing over time. Am I just lucky that it's still running, or am I missing something? Is it waiting to go down on me, and I don't have redundancy in my feed here? If I'm all in one eggs, all eggs in one basket situation with one mains
Yeah.
transformer, I'm screwed. So that kind of risk assessment, which is not just a field risk assessment of doing jobs, but more like a has op, has id, plant wide risk assessment planning. That's where people have this epiphany and they go to management saying, hold on, you can't just not allocate dollars for this job. I need some money because I have to maintain this big behemoth circuit breaker system with my transformers, etc. So there is a
Right.
big gap, which is supposed to be in maintenance and supposed to be in operation. And sometimes people drop the ball. Nobody knows who's got to do what until something breaks or somebody realizes there's a big hole.
Yeah, and I could see a lot of facilities out there, they would never imagine that they had to go into the switch yard to do anything. Um, so I know, like, if you're applying NFPA 70E to most of the stuff on your site, then you're going to be fine. When it comes to that main transformer and everything in the switch yard, is it still NFPA 70E or is it something else that you need to know
There
about?
are a few standards that come into play. NFPA 70E is definitely one of them. There's the sister standard that goes hand in hand with 70E, which is 70 Bravo, the maintenance standard, or in Canada, we have CSA Z462 and 463 that go in
Right.
tandem. In fact, I know Kerry Hyde on the CSA Z463 committee. He was, I'm with Shermco now and and you mentioned some names. Mike Barr is a good friend, but Mike Doherty, he was kind of one of my mentors that I went to work for him. And Kerry Hyde at that time was his boss. He went to work on the CSA 463 committee, and he's responsible for maintenance standard in Canada. So that standard. There's also standards from NERC, the National Electrical Reliability Commission, which handles utility companies. And there's also NETA, the National Electrical Testing Association. Actually, they kept the N. It's now International Electrical Testing Association, but it's
Mm.
still NETA. So you put all of these together and you get all the do's and don'ts and how often you're supposed to look at and maintain and operate and do everything that you need to do to keep that substation going. Like, case in point, fans on the transformer. They're immensely important. It's crazy how much a role those cooling fans play. Uh, a typical large mains transformer, when you look at the nameplate, it'll have something like 30/40/50 MVA. So what that means is if both sides of fans are running, that's on the primary and the secondary fins, you can pull up to 50 MVA on that transformer. You got fan failure on one side, you got to derate that transformer down to 40 MVA. And when you have
Hmm.
none, you can only pull 30. So you have to plan your loads depending on those fans. If you try to do more than what the transformer can give you, the overheating is going to make that transformer very distressed and upset. Many people don't know that.
Yeah, I was just gonna say, like, I know here in Canada, the Z 463 really hasn't been around that long. Um, from your experience, Sam, you visited a lot of sites and a lot of different companies over the years. How, just ballpark, what percentage of companies out there do you feel have a good handle on electrical maintenance? Like, is it low
It
or
is
high?
low. Unfortunately, the situation in the US and Canada is a lot like our technicians and our uh, baby boomer installed base of people. We have good quality equipment, but lacking maintenance. NETA did a recent study. This is about 10, 12 years ago on circuit breakers. And they found that
Hmm.
they studied about 500,000 large circuit breakers. I'm talking low voltage power circuit breakers, medium flat switchgear, that sort of stuff, not the small breaks, uh, the uh, the ones that you don't need any maintenance on. The yeah,
Mm.
the molded case and insulated case, not those. So what NETA found is that 50% of them had maintenance issues, not being lubricated or cleaned
Well,
all the time. Half of them. 25% of them had trip issues. That is, they won't trip on the threshold that they're supposed to, or on the dial for overload or overcurrent or ground fault. They won't trip at that threshold. So it's an unknown. And yeah, and 10%
just repeat that. How many breakers they looked at again? 500,000 breakers. 25% of
have
those.
trip issues. Or they might trip at a higher threshold. So you're planning your whole coordination study, the fact that that breaker is going to trip at 950
Sure.
amps. But actually, that breaker's a little damaged because it's seen some PTSD and it's going to trip at
Yeah.
2000 amps instead of 950.
Yeah.
And you're counting on it with your studies so it's not going to obey. It's going to be like a disgruntled employee, that breaker in your single line. And the last part of that study, John, is incredible. The last part is it makes me shake my head. 10% of those breakers do not work at all. They're like bus bars. The open
Wow.
close doesn't do anything, and trip won't do anything. They're stuck because nobody has operated them. Either they're staying closed, or uh, which is the scary part, or nobody's used them, so they're just jammed. They won't work. 10%.
Yeah. Yeah, I mean, I can believe that. Like, I know we've had just in the past couple of years, a few phone calls when someone has operated their main switch or breaker thinking that it's going to shut the plant down, and come to find out it doesn't do anything. You're right. It's another set of bus bars, and now they don't know what to do because they can't shut the plant down. Um, but just for people listening to just kind of what that all might mean, we've talked a lot about arc flash before. So if you have arc flash labels on your equipment that's showing a certain value of incident energy, um, there's a 10% chance that the breaker that's supposed to trip, well, maybe that's too high, but you get the point. I don't know the math on it, but 10% of the breakers that were studied will not trip, which means that that label is useless. And then 25% of them are going to be a little bit slower, maybe, than what was programmed into that study. So that's just, I guess, what I want to say is the importance of having a good maintenance program. And because really, like, is there any, Sam, like, we have these standards out there for maintenance and electrical maintenance, but is there any, like, when it comes to safety, I think people get that they need to do something because if someone gets hurt, they're going to be held liable, and not to mention just to keep people safe. But when it comes to maintenance, I don't know if they feel the same way. Like, is there any enforcement at all in maintenance, or is it sort of left up to companies to just decide, like, well, it hasn't broken yet, so let's cross our fingers and see if we can go a few more years? Or yeah,
You bring up
do you
you
know?
bring up an interesting point, John. So all this time, 70E, 70B, they have been advisory standards, but enforceable by non-compliance. As in, you can do what the heck you want, but if there's loss of life, loss of limb, an incident, OSHA comes to your site. This is in the US. There's no OSHA in Canada. They'll cite you for not following these standards, for not doing maintenance. Now,
Right.
the hard part about maintenance is it's not slam dunk linear like electrical safety for personnel, which is 462 or 70E. Maintenance has another flavor, as in two identical breakers will have different maintenance requirements depending upon where they're installed in the single line. A
Mm,
breaker, which is installed upstream, has higher priority than another identical breaker for another load because this has a greater impact on your production. So, not only do you have a maintenance schedule that you have to follow for the breakers, but there's multipliers of how often. And that multiplier is determined by the importance of that transformer or breaker in the hierarchy of your plant. That is the single line. And
mm,
you can do computations for hierarchy with 70B or with NETA. And you'll find that the answers are not the same. It's like wearing two different wristwatches. You're never going to get the right time. So what it, they advise you to do, and I learned this from Alan Burstein, one of my mentors. He's lead for Procter& and Gamble worldwide. So he kind of set all the guidelines for they have 200 plants all across the world, Procter& and Gamble. So what
mhm,
he told me is we take 70B and we take NETA and we take a hybrid and then we make our own. This is how, like a car, right? This is I'm taking this car only for groceries. So I'm gonna do oil change only once every 1 year. But this car is my main bread and butter. It's doing all the field work. So I need to change the oil every 6 months. So you have to take all the standards, make them your own, assign tasks for maintenance and intervals based on priority and based on where equipment is in the plant diagram.
mhm. No, that's good. And yeah, and I think too, like, that's just something that a lot of people um, maybe are intimidated by a little bit when they look at these standards, because when you read through them, everything is in there that you could possibly think of, and then it's your job to kind of figure out, well, what applies to my plant and what frequency makes sense. And yeah, definitely. Um, Maybe just switching gears a little bit. And you spend a lot of time doing electrical safety training over the years. I'm always curious, just with the different groups that you're training, what are some of the things that you still feel people are just not understanding?
There's some very simple concepts. I always tell students in my class, I don't want you to think you came to a 3 or 4 day class with Sam and you heard blah, 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 electrical safety, yada, yada, yada. I want you to take something in your fist. I want you to make it concise. And what I find is people who have taken classes prior haven't been told simple concepts. Number one, like working distance. Working distance for low voltage is 18 inches. Why? Because that's arm's length. So if you violate that working distance and you're playing touchy feely, coming too close to energize equipment, that arc suit you wore per the label that was designed for you being arm's length away is not going to protect you unless you seriously uh, oversized your suit, stuff like that. Or the difference between a safe work zone and electrically safe work condition. And the fact that even when you're doing lockout tagout, which is a fancy way of, I mean, the electrically safe work condition is the book's way of saying lockout tagout. Part of that lockout tagout is to assume that even though equipment is de-energized and locked out, you still have to do absence of voltage, live dead live checks. And you have to treat that situation as a safe work zone where it's still
Hmm.
energized. So people sometimes don't get that. They're mechanically doing stuff without realizing that simple concepts is that when equipment is energized, those three boundaries are those magic lines are there. And the way to get rid of them is normal operation, or you could barrier the the energized equipment. So little concepts of the rules of a safe work zone, how you achieve a safe work condition, the steps to get there, verifying the lotto. I find too many instructors just like PPE orientated all the time.
Yeah.
That's like, driving a car and just saying the airbags, 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 the seat belts, they will protect you. Like talk about safe driving
Right.
too, right? So I spend a lot of time on risk assessments. Like how good is your JSA
Yeah.
form? Show me that form. First page needs to have shock and arc flash. Now they say electric shock. It's like, okay. But, and the second page needs to have all other hazards. Like show me how you've mitigated and not just blindly just check everything off, right?
Yeah, I had a conversation the other day with someone about something very similar, and just around that, like PPE is the answer for everything. And there are people. Well, here's the scenario. So he uh, he was coming across some work, and they were applying temporary protected grounds to um, some high voltage system. And the thing is that the system had already been proven de-energized. So it was already grounded somewhere else. There was no way that anything was going to happen. And I don't exactly know the reasoning for the second set of grounds, but the point he was making was he approached the worker who was in a full blown 40 cal arc flash suit. Everything's already proven de-energized, and asked, well, why are you doing that? And he's like, well, we just, it's better safe than sorry. And that's great. But the problem with it is that that individual actually doesn't understand risk assessment. So they're just blindly putting on PPE anytime they do anything that they think is risky. The problem is that if you don't know why you're doing it, then you also aren't going to know when you're doing something that you should actually have it on, and you might not because you can't recognize those hazards. So yeah, I totally agree with that, Sam, that you need you just can't take the hit the easy button and just put the PPE on every single time blindly. You need to understand what you're up against and why you're wearing the PPE and when you should be wearing it. So no, that's a great point. Um, is there? Maybe we already talked about this, but I know you mentioned with like this switch yards and that in the new course. Are there things that you would teach people in that course that are very different from the just the basic arc flash and electrical safety training? The one with utility and in around the substations and that. Like what's sort of the extra safety things that you'd need to learn about for that?
Oh yeah, absolutely. When you're doing substation training, so this applies, John, to wind and solar energy too. They have specific terms. So in the industry, when you're training people for electrical safety, there's the tower safety training, and then there's the BOP, which is balance of plant. for wind, which is basically everything from the pad mount to that transformer. Substation training, they call it balance of plant, is because you're it's unlike a refinery, say, where you have a distinct line side and a load side. When you're generating power, it's tricky. There's no line and load. There's a generation side and a utility side. So that you got to balance that. So they
Mm.
call it balance of plant. And for solar, apart from the solar panel and the charge converter, everything else, again, identical to wind, where they're taking the DC voltage, chopping it up, and then making it 34.5 kV, which is standard as collector voltage, and sending up. They call it balance of system, or BOS. So in the training for substation BOP BOS, I would go through every component. What is that? What is that? The vacuum circuit breaker doing? How do you maintain it? How do you look for signs that it's going to go south on you? What? Uh,
Mhm.
Absolutely. Transformers. Are you taking oil samples on your transformers? Are you uh, looking for cooling? Are you looking for the sudden pressure relay? The transformers have a big oil tank, and there's whenever something goes wrong with the transformer, the first thing to sense it is the oil. It's kind of like a blood sample for us, right? The doctor can tell what's wrong with you.
Yeah.
So if that transformer is starting to get upset, she's making ethylene, acetylene. That means there's something seriously wrong with that transformer. But otherwise, to other gases, each one tells a story. If there's methane, then you got arcing going on. If there's carbon monoxide, carbon dioxide, then the paper and the wood in the transformer is wearing out. Those need to be changed. Or there's a winding short, you get another gas, that sort of stuff. So we'll go through that part. We also go through switching order, that which you don't pay so much emphasis to in planes. Why? There's been a recent incident. Somebody put a video I saw. This guy is in full 40 cal suit, as you say, and he's cranking a GOAB, uh, the gang operated air brake
Yeah.
switch in the switch yard. And as he's doing it, the damn thing arcs as he's opening it. So he
Yeah.
just caused serious damage to the switch. Now, why did that happen? Because he didn't kill the breaker first. Breakers have arc chutes. They're rated to be open under load. A switch is not. It's like, your mom pulling the plug off of a toaster when it's still orange in the toaster. Like, "You don't do that, mom. The thing's going to arc, right?"
Yeah.
So little stuff like that, right? Which people, like you say, they're only suiting up, but they don't know why they're doing it. So that those switching orders have to be followed. And it's extremely dangerous when you can't kill utility power. So you have your utility feed live, so you have to open up switches and breakers before you can do any maintenance on your side of the switchyard. One little thing could kill
Mm.
you. And to your point of why you need to apply multiple grounds, there is sometimes a reason, especially as you start getting into higher voltages. 15 kV, you're okay. But once you get into 33 kV in the UK, 69 kV here, or 100 kV or so, just a aluminum line will start picking up field from adjacent energized components and start developing eddy currents. Once it hits 200 volts, if you touch it, you just died touching a de-energized conductor. That's why we say wherever you're working, you call them personal protective grounds because they go with you. They're for your personal protection. Wherever your area of work is, you put grounds, regardless of grounds being put 20 feet away. They're personal, they're yours. Yeah, stuff like that. I mean, I got so much for the substation's a 4-day class.
Oh, wow. Yeah. Yeah, so actually that was, another thing I wanted to ask you about. You mentioned solar, you mentioned wind. I know I've talked to a few different people, and they say that these industries are kind of growing so fast now that it's as if they're hiring anybody and, everybody to come and work on these things. Are you kind of finding that too, that the technicians working on solar, working in wind, if you looked at what the definition of a qualified electrical worker is, Are these people anywhere close to that, or what's been your experience there?
It's a mixed bag. There are some companies who go gung ho, hiring anyone from a forklift operator to uh, to somebody who's to climb up buildings to wash windows just because they have climbing experience to work on a wind farm. And you'll realize, and there's some companies now. There's a new organization called GWO, Global Wind Organization. They've only started implementing their scope in the US since after COVID, since 2022. So to work on a wind turbine, if you are affiliated with that club, you have to be GWO certified. But all of that talks about climbing and working at heights and manual handling. There's no electrical safety component. So for electrical safety, it's still us. And problem with sending an old guy like me up on a tower in the nacelle, I have to be GWO certified. So it's like, you're getting a geriatric wire jockey safety guy to go become a wind monkey. So I cringe at that. And solar, people don't understand that capacitors and batteries and solar panels have to be treated like they're always energized. You can't lotto something that's always energized. So people don't understand
Hmm.
that. And solar panels, if they're damaged and you put water on them, people think they're de-energized. But the current, the fault current when a solar panel is damaged by hail or stone and there's rain on it, the water starts to short all the panels. The current goes up exponentially and can cause more than rated maximum current of that panel can kill people. And with the advent of the newer generation, perovskite solar panels. So you see, solar panels in the past were only 15, 16% efficient. And nobody cared because the energy from the sun was free. But the
Yeah.
newer materials, rare earths and these perovskites are reaching 30% efficiency, double the amount of current. So you find smaller solar panels or the same size with twice the fault current capability. So we're not seeing industry pick on the hazard part. They've caught on the technology and they're excited, but the handling and the hazards that come with it, they're still deer in the headlights, unfortunately.
Mm. Yeah. Well, I hadn't even thought about like hail or damage like that, and it almost sounds like we've got a whole new can of worms of hazards to be aware of and things that could go wrong. So that's interesting. I know you mentioned before we got going, kind of a new organization that you're getting behind. Do you want to share a little bit on that and what that's all
Yes,
about?
John. I mean, after some good work with Leaf Electrical Safety, I proudly wear that badge, and a great amount of time with Shermco. I just have personal health issues that are slowing me down physically, but my mind's still that that wind monkey. So to proverbially speak, what I'm trying to do, John, is look at companies and countries around the world. I just visited Ghana early this year, and we set up a school and a library in the name of my little girl who passed away. She would have been about 21 or so now. So in her memory, and we also did a GoFundMe, raised about $2,500, which helped 300 refugees at the Buduburam camp in Ghana. Ghana is a safe country, but has lots of countries with extreme strife and war all around it. So refugees keep pouring in there. That made me think, why don't I do something in terms of electrical engineering and safety on the same grounds? So was born the concept of ESIPAC, or Electrical Safety Industry Practices Actions Committee. We are a proactive version of OSHA, NFPA, IEEE standards that just are sitting in a book. They're hard to read. You need uh, expensive consulting companies to decipher, implement, and teach the gospel, the wisdom of what's in that standard of how to and what not to. And so, what I want to do is to
Mhm.
gather a world panel of experts. I've got three thus far. Ruben Lares, Marcin Ruda from Poland, and David Davenport from the UK. They've joined SEPAC. I'm still
Yeah.
looking for more people and a good marketing engine to. And what we want to do is to get these companies who can't afford to pay for a full electrical safety program a meager stipend, annual stipend that gives them access to Q&A. Any of the experts on the panel can answer anything. So our aim is to save lives, to minimize equipment downtime, and to give them quality electrical engineering and safety support so that their production is on par with the West or with any developed nation, economy, or country.
Sounds fantastic, Sam. We could definitely, if we got a link or anything to share, we can put that in the show notes for sure. And I guess just one, just before we wrap up here, if someone did want to reach out to you, what would be the best place that they could find you? Is it
Yep.
probably on LinkedIn or some other
Yeah,
platform?
that's the
Okay.
only social media I really use, LinkedIn, and sometimes I look at posts of like-minded people and I find what's going on industry and worldwide. Uh, I put not only observations, but sometimes I'll see what's happening, open up an engineering textbook, and also kind of add a little bit of my 2 cents of geek advice that was, Lenz's law or Bayard-Savage law that caused this field. That's what you need to look up, and then people half the guys
Mhm.
will not understand. Somebody will write, "This isn't rocket science, this is just electrical safety." So, but I like that little pushback and keep in touch. Yeah, LinkedIn absolutely is the way, and, I welcome anybody, I if I can help, in this field, it took me so long to accumulate. I'm one of those people who was a late bloomer. There's uh, uh, young guys who drop out of school to start companies and become millionaires. I'm the opposite. I took forever to kind of just get it all together. So in the sunset years, but I'm glad to share because I think it's I think just like healthcare, quality electrical safety and electrical engineering should be available to everybody regardless of their economic condition.
That's great. And that's a great place to close. So I want to thank you again, Sam, for coming on. It was great to talk to you.
Thank you,
Thanks.
John.